We're going to start with a review question from Friday. Remember Friday, the main new information we learned was about arc length and area of a sector. So this particular problem, again, is a problem that we did in class, but it is on tomorrow's assignment and it is on your actual exam. So it's important that you do know how to do this particular problem. Okay, so this particular problem says a circle has a circumference of 16 pi, an arc length of 356 pi over 45. What is the central area in degrees? So let's write down the given information. We're told the circumference is equal to 16 pi. We know circumference is 2 pi r. Let's set it equal to 16 pi. We're told the arc length is 356 pi over 45. And on Friday we learned arc length, which is often described as like the crust of the pizza, the outside crust, has the formula arc length equals r theta. In this case, your arc length is given. It's 356 pi over 45. We don't know the radius of the circle. We don't know the central angle. In fact, my whole question is, what is the central angle if you're told you have an arc length of this amount and the circumference of this particular circle is this amount? Well, if I look up here, I can see with circumference, there's only one variable, and that's r. So let's isolate the r by dividing both sides by 2 pi. The pi's cancel on the right. 16 divided by 2 is 8. Now I can take the 8 units, which is the radius, and I can substitute it in the formula for arc length. 356 pi over 45 equals 8 times the central angle. To isolate the central angle, that's the purpose of this problem, I'm going to divide by 8. As a reminder, I'm going to do it really light so I can go over the top of it. When you divide by a number, you really end up multiplying by the reciprocal. Multiply straight across, I end up with 356 pi over 360. And I can reduce this down to 89 pi over 90, but this would still be wrong because the final part of this question said, what is the central angle in terms of degrees? So now I need to transfer this into a degree. To do that, pi's on top, pi goes on bottom. The pi's cancel. Take 89 times 180, press enter, and divide by 90. And your answer should be 178 degrees. Please make sure you have good notes so you understand how to do tomorrow's homework in class. You have to get it right. Please make sure you have good notes. The next problem, we're going to go back and do the watch problem that we did on Friday as well. I'm going to start by reading the problem while people are finishing writing this down. Your watch is running fast and needs to be set back. When resetting the watch, the minute hand on the watch subtended an arc of 8 pi over 3. Suppose the radius of the watch is 1.4 centimeters. What is the length of the arc on the outside of the watch that the angle subtends? I'm going to flip this to the other side just to save some paper. And let's just draw a pretty small watch. So we're working with an analog watch. We have the hour hand and the minute hand. We're told the minute hand is 1.4 centimeters. We're told that this particular clock is running ahead. And so when it says the minute hand of the watch subtends an arc of 8 pi over 3, that means we need to take this minute hand and we need to set it back at a central angle of 8 pi over 3. For most of us, it's hard for us to imagine, well, how far is 8 pi over 3 setting it back? So the first part of the problem says, let's start by identifying the length of the arc on the outside of the watch that the angle subtends. That means how far on the outside of the clock do I need to take this minute hand and move it back? Not in terms of minutes, just in terms of length. So arc length equals radius times central angle. The radius is 1.4. This particular sub-angle or subtended angle is 8 pi over 3. Because we're working with the real life or modeling a real life scenario, let's put this in terms of a decimal and round it to the nearest hundredth. So I need to take this, excuse me, I need to take this minute hand, and on the outside, I need to move it back 11.73 centimeters for it now to be at the right time. The second part of this question says, suppose the radius of the watch is 1.4 centimeters. We've already been given that information. What is the length? Oops, sorry, we've already done the length. If we read the watch currently as being 1:13 p.m., before we reset the minute hand, what will the new time on the watch be? So it's 1:13 before we reset it. What will the new time be? So let's do this in detail. This is the most difficult for most people. I have a really small little circle here. This represents my watch, okay? If I start here and I go one time around, how many minutes have I just gone? Okay, so I'm going to write time 60 minutes. Now, on the length on the outside, we now refer to that as the arc length. The arc length, okay? The arc length of this particular clock would be r times theta. Well, I know the radius is 1.4. Excuse me. I know, yeah, the radius is 1.4. And to go once around a circle is 360 degrees. 360 degrees is equivalent to 2 pi in terms of radians. This is the distance for this particular watch to go one time around on the outside. So here's the time to go one time around. Here's the distance. I'm making a ratio. We want to know how many minutes do I need to set this back when we know that we need to turn back the minute hand a distance of 11.73 centimeters. Cross multiply. I'm going to take 60 times 11.73. And can you please take 2 pi? Remember to use the pi symbol and not 3.14. 2 pi times 1.4. And we're going to round to the nearest hundredth. So a lot of times students struggle with this rounding for this particular problem to the nearest hundredth. So I look at the third number. The third number will bump the 9 up to a 0, bumping the 7 up to an 8. So this rounds to the nearest hundredth to be 8.8. To isolate the x, I divide both sides by 8.8. And we're going to eventually round to the nearest minute. So 79.78 would be minutes. Remember, x is in terms of minutes. But when we round to the nearest minute, when I round to the nearest minute, I end up with 80 minutes. It's an Amber Alert. For those whose phones are going off, it's an Amber Alert. Okay, 80 minutes. So it's 1:13. How do I go backwards 80 minutes? And you can have multiple ways to do this. Here's one way to do it. I'm going to split 80 up into 60 and 20. To go back 1 hour is pretty easy. I was at 1:13. Now I'm at 12:13 p.m. Okay, I'm going to split up 20 into 13 and 7. If I go back 13 minutes, I'm down to 12 o'clock p.m. And now if I push back 7 minutes, I'm down to 11:53 a.m. Turn to your partner. This is probably one of the most difficult problems on your test. Definitely the most difficult word problem. You have 1 minute to discuss this with your partner before you go on to the next problem. which part of the arc length? This part of the arc length? This one down here? This one right here? Okay, so you have a watch, right? Let's just pretend this was analog, so it was a circle watch, right? One time around is 60 minutes. Now I need to do the length on the outside, known as the arc length, right? So the arc length is given by this formula we learned Friday. So what is the radius for this particular clock? 1.4. And then the central angle to go one time around any circle, is 360, right? Do you agree with that? Well, we can't write 360 down because that's to be turned into radians, which is 2 pi. It is, but what may change, so in other problems, this will be the same. When we're creating this ratio, this will be the same and this will be the same. But what's going to change is every watch is slightly different size, right? So the radius of every watch will change. So that 1.4 is going to change from watch to be a different number. Okay? But the way this is set up will be the same. So you're asking, will this be 60 when I set the ratio? Yes. Will this be 2 pi? Yes. But this particular number will depend on what they give you for the given information. Does that help? Yeah. Okay. So what I was surprised about, how many people, if I can have your attention here, how many people are in charge sometimes of doing grocery shopping for their family? Okay, 3 or 4 of us. Okay, so what I was shocked about is in my previous class, I said unit price, and nobody knew what a unit price was. So maybe it's the terminology you don't understand. Okay, are you ready? You're given $2, and you are told to purchase as many small limes as possible. Okay, and it just happens that you can perfectly buy, forget about taxes, 20 limes. Turn to your partner, grab a calculator. How much did each lime cost? You're given $2 to purchase limes, as many as possible. You could get exactly 20. How many did you purchase? Don't tell me, tell your partner. Okay, ready? Esme, 25 cents per lime. Agree or disagree? Agree. Okay, why do you disagree? What do you think it is, and how did you get an answer? Hold on, people are talking.
We divided 2.00 over 20.
So you told me, hold on, you divided, what was your top number? Please don't talk. What is that? Okay, so you took the price, what I'm giving you, and you divide it by what? By how many, which we're going to write down the quantity. And sometimes we talk about this in terms of the area. Please write this down. So you're telling me, did you end up with 0.1? Yeah. That means each lime was worth not 1 cent, but 10 cents. There is this myth, and I believe stores like Sam's Club and Costco really get customers with this. Customers often believe that the bigger the quantity, the cheaper you're buying things. So like, oh, if I get a peanut butter that's this big versus this big, it's going to be cheaper. Not necessarily always true, okay? If you look underneath the price of everything at your grocery stores, it's going to say the unit price, and it will divide it down generally based on the ounces, and it'll say how much it is per ounce. So peanut butter, for instance, you can look at the same brand in different sizes, and you can see what is actually the cheapest one to buy. Does that make sense? So sometimes it's cheaper to buy like 3 small peanut butters versus 1 big one. How many of you knew that? It's okay if you didn't. Like 2 or 3 of us. Okay. This is a life skills class. I am so glad you guys are here. Woo! Okay, are you ready? We're going to put some pressure on you. Forget about which pizza looks better. Luis, you focused right now? Yeah. Okay, forget about which pizza looks better. Like in 3 hours, you're going to want those slices. Okay, so can everybody split your paper? You don't need a large portion, so it's not the whole page. Split a small portion like a T-chart. The left-hand side will be slice A. You're going to label it. The right-hand side will be slice B. I'm going to give you certain information about both slices of pizza. And I want you to be an informed buyer. I want you to choose the slice that is smartest for you financially. So you are going to base that upon the unit price. Luis calling you out here. Ready, Luis? Look at your paper. What is unit price? It is what over what?
Price over quantity.
You got it. Price over quantity. Now, I have had in the past people say quantity, oh, there's one slice. When you just have one slice like this, you're taking the area. So it's price over the area. Good so far? Bless you. On your paper, please write down somewhere, area of a sector. This is what you learned on Friday. Area of a sector. Remember, a sector is like a slice of pizza. It's not a triangle. It has a curved edge on one side. Okay, area of a sector equals 1/2 r squared theta. Theta is the central angle, and it must always be written in terms of radians. So slice A. Again, Luis is going to call back to you because we're learning this. So tell me again, what is the unit price? Luis, it is?
Price over quantity.
Okay, so does everybody say we're already given the price? Now the quantity is not one slice. We're going to figure out the area. So we'll take 125 divided by whatever the area is. Let's all round to the nearest hundredth. Okay, so look at that formula we just wrote down, 1/2 r squared theta. So we already have the 1/2. Ken, from this slide, can you figure out what is the radius?
Yeah.
But you can't just write down 8. What do you have to write down? 64 because you're squaring it. Sure, you could write down 8 squared, but 8 squared is 64. Here's where students in previous hours made a mistake. For that theta symbol, which looks like a 0 with a line through it, they wrote down 25 degrees. Why is that wrong? Okay, so you're going to do that. Put it in terms of radians, get that area, round it to the nearest hundredth, and then take price divided by area, and I want you to round it to the nearest hundredth. So it'll be something like this, 12 cents, 4 cents, 3 cents, whatever, okay? With your partner, you have 30 seconds, go. You're welcome to look up to see if you are doing it correctly. Do not use 3.14. Please actually use the pi symbol. How many people were able to come up with, once rounded, to 9 cents? Hands up high so I can see. Okay, so let's break this down a little bit better for me so I know where there's some confusion. Who was able to come up with this area? Okay, am given a unit price, so I take the unit price, I take the cost of the slice of pizza divided by the quantity, the area, and then I round it to the nearest cents. What does that mean? That means that slice of pizza, this is like, can everybody look up here? I'll do it here so everybody can see on the screen. That means every square inch of this pizza is worth how much? 9 cents. Okay, look at the next slide. Regardless of what the pizza looks like, that's the key. Okay, regardless. Oh, really? Okay, all right, here we go. Look at her. She's like defending Costco or Sam's Pizza. You're such a good buyer. Okay, do slice B in the exact same fashion, and then I want you to compare financially which slice would be better to buy. You have 1.5 minutes with your partner. Begin. Please make sure you're talking with your partner through it. Show work on paper. It'll help you for tomorrow. Yes, please.
Which would be 5 over 8.
If I remember right from a previous class, it's just ironic you get the exact same area, am I right?
Yeah.
So if they were the exact same type of pizza and they looked the exact same, and especially if you were going to buy for a large quantity of people, like a large birthday party, would slice A or slice B, which the way they cut it would be a better purchase for you? Slice A. Why? Because it has a cheaper unit price. By how many cents? 2 cents. Thumbs up or thumbs down right now? Where do you often see unit price? Does anybody in here maybe work with your dad or grandpa or whoever on installing flooring, like tile flooring or wood flooring sometimes? So on any box, you're going to see what is the unit price, and it's done by the square footage. It'll say how much it is per square foot. So you buy a big box. Let's say it's like planks of wood, right? You buy a big box, but on there it will say how much it is per square foot. And that's how, when you're determining as a budget, what are you going to spend, those are the things you look at. Okay, it's the unit price for that. Okay, now we're going to get into visuals that some students really caught on to first hour and some students definitely struggled with. I'm not going to teach you the shortcut right now because I want you to figure it out for yourself along the way. If you never figure it out, but you visually can come up with the answers, that's what's important. Please write this down. Identify three positive and negative coterminal angles. Identify 3 positive and 3 negative coterminal angles. So you're going to take notes on the first one, but basically you're going to be following what I do. The second problem we do, you're going to do with your partner. Okay, here's the first one. So example number 1 for this, because we're going to do 4 examples. I believe 4, maybe it's a few more than 4. So here's the first one, example number 1. Negative 190 degrees. So first of all, I think most students learn best by visualizing where this is. So make yourself a very simple, what you would refer to as an XY chart. Now when I draw the unit circle, because it's negative, on Friday we learned that from this position, I'm not going to go up, I'm going to go down. So I'm going to count as I go. Here's 90, here's 180, and I need to go an additional 10 degrees. So I'm stopping right here. So I'm going to come up with 3 positives. Positive means I have to start at my starting point, but I have to always go up. So here's the first one. From here to here, this is a coterminal angle. You end on the exact same point on the unit circle. I went from here to here. So how do you determine that length? There's different ways of doing it. One way to say is, hey, I know that you're not quite at 180. You're 10 degrees less than 180, which would be 170 degrees. That's your first positive coterminal angle. Now your second one needs to start here again. It needs to end here again, but it needs to go 1 revolution around the unit circle first. So please watch. How many degrees have I just gone? But then I need to go an additional 170. So please take 360 plus 170, and you should have an answer of 530. I asked for 3 positives and 3 negatives. So this time, I'm going to start here. I know it's getting kind of confusing with all these. So this time, I'm just not going to draw it. Okay, I'm going to do the motion with my pen. So I got to keep going here. So there's 1, so there's 360, plus 360, plus 170. So 360, 360, and 170, and that gives you an answer of 890. When you say positive coterminal, you're ending here, and you're always going upwards first. I'm going to draw the exact same angle again, so it's not so confusing. So here's 90, 180, and 190, okay? But this time for negatives, instead of going up, I have to go down. Now, the mistake I saw students making in first hour is they go, okay, I'm going to start here, and I'm going to end here, so it's negative 190. But I've already been given that angle, so I can't write it again. So this time I'm going in this direction. I have to stop here. So here is, can't stop here because I've already done that once. So once around, how many degrees? 360. Forget about positives and negatives, yep. Here's 360 plus an additional 190. So grab a calculator. What is 360 plus an additional 190? The answer is? What is it? Yep, I got that, 550. But because I went in the direction of going down, it makes it a negative. Okay, so the next time I start here, I've already gone once around and then back to the point. So this time I have to go twice around. So 360, 360, 190. And correct answer is, I have negative 910. Anybody else have that? Please figure out the third one. Check my work, 1, to make sure I did it correctly, and 2, to let's see if we agree. Negative 1270. Are we okay with that? Okay, so here's my suggestion. You ready? Here's my suggestion. It's going to make a lot more sense when we get to working with radians. After you figure out one positive, what do we just get to do? Add 360, add.
360.
After you figure out this first one, forget about it being negative, add 360, throw on a negative. Add 360, throw on a negative. Okay? So first figure these two out, then we add 360, add 360. Same thing, but these will have to be negative, these will have to be positive. With the help of your partner, you're working together. I must see you working together, so let me just make sure everybody's in pairs. Miguel, can you please pull a chair up on either side of the people in front of you? You have, with your partner, 2 minutes to do this problem. I'll be doing it at the exact same time. Please do not do it in this fashion. Hey, I'll do 3 positive, you do 3 negative. Work together. Negative 50 degrees is your problem. Example number 2, begin. Oh, Miguel, can you work with Brenda? I didn't realize Trinity was gone. Thank you, Brenda. Are you guys already done? Hands up if you're done. Really? Can I read these positives to you? Do you have 310,
Yes.
670, and 1030?
Yes.
Okay, so you figure out the first one. I have negative 410. Then forget about the negatives. We'll add those on afterwards. 770, 1130, go back with the negatives.
Yes.
Thumbs up or thumbs down right now? Wow, you guys did much better than I was expecting. Okay, so here's your next one. This is not simple stuff. Here's your next one. So I'm going to teach you 2 different ways to do this. I'm going to teach you the long way that's less complicated. Luis, paying attention? I know, Alexis often makes you get in trouble, doesn't he? He's just quiet about it. I hated those kids in high school, you know. They never get called out, but they're the instigator. It's Alexis. Just know that I know. I'm going to be grading his test harder from now on. Okay, here's your problem. Most students prefer to work with degrees. How many of you, by raising hands, I like degrees better? So I'm going to teach you how to cheat here, but only cheat for half the time. Because if you cheat the whole time, it's going to take you 3 times as long to do this problem. Here's the first thing. You ready? I want you to forget about the negative and simply turn 2 pi over 3. And some of you know it in your head, so don't shout it out. Turn 2 pi over 3 into degrees. Does anybody want to review on how do we switch from radians to degrees? Okay, so from radians to degrees, you're going to take 2 pi over 3, and notice the pi's on top, so pi goes on the bottom and 180 goes on top. The pi's cancel. Take 2 times 180 and divide by 3. You should get an answer of 120, but remember, now it has to be negative. So everybody write down negative 120. Okay, let's just draw ourselves a very simple graph. And 120. Okay, so I have to go backwards. Here's 90 going backwards, plus I need an additional 30. So here's where I am, right here. So my suggestion for you, we're going to do 3 positives on top, and we're going to do 3 negatives on the bottom. Here's what I think is easiest for students to understand and also does not waste time. Let's first do this in degrees. Only 1 positive on top in terms of degrees. So in terms of degrees, if I do a positive, I start here and I go all the way around until I get to here. Okay, well, how can we do this? There's different ways. I don't want to teach you some of the tricks until you kind of figure those out on your own. So here's the long way of understanding. I have 90 and 90, so I'm at 180. And then this was 30. This entire thing is 90. That means this has a remainder of 60. So 90, 90, and 60 is what amount? Okay, so very, very small, write down 240. Can you now take 240 and change it back into a radian? You have 25 seconds, go. You may have memorized it. If not, do it on paper. The answer should be 8 pi over 6, which reduces to 4 pi over 3. Now I'm going to teach you what is the fast way of doing this. Look back to the last problem. Let me grab my work. Look back to the last problem. After you figured out the first one, what did you just keep adding? 360, and then we add 360 again. But in terms of radians, what is 360? Okay, so don't do this. But what I want to do is I want to do 4 pi over 3 plus 2 pi, and then whatever I get for an answer here, 4 pi over 3 plus 2 pi, I want to add additional 2 pi. Thumbs up or thumbs down if you get that concept. So here's the fast way of doing it. Because they both contain pi's, we get to initially forget about the pi. Grab your calculator. In parentheses, take 4 divided by 3, do not place a pi, then add another 2. We're going to get a decimal and we're going to turn it back into a fraction by hitting math, fraction, enter, enter. Then, as I write down 10 over 3, I get to throw a pi on top. Okay? Now, pay close attention. The bottoms stay the same. What happened to the top? Okay, you ready? So we have 10 pi over 3. That's this portion, 10 over 3. And now I want to add another 2 to it, put it back into a fraction, and I have 16 pi over 3. Again, what did I add to it? A 6. Why are they positive? Turn to your partner, 5 seconds. Why are they positive answers? There's only one reason. With positive coterminal answers, you start by going upward. When you go up, your answers are positive. Each one of these will be negative because you're going. Okay, so the first thing we have to figure out is let's do it in terms of degrees just to simplify things for you, and then transfer it back into radians. Okay, here we go. You ready? So let's do it together. What is this amount right here in terms of degrees? Negative 120. So let's only think in terms, let's just think 120 to make things easy, okay? This is 120, but I can't stop here because I already have that answer. So what I really need to do is I need to go once around and then end up back here. So once around is 360 plus an additional 120. Please add those up. Okay, I'm going to very small, I'm going to write 480, and I'm going to put a negative sign in front. Can you please take 480 and transfer it back into a radian measurement? Okay, and Esmeralda, why would this be wrong for a test? There we go. As long as you put a negative, whether it's on top or the side, or even down below, as long as there's only one negative, our answer is right. Okay, let's go back to our notes. How do we get from one to the next each time? Add 360, which in this time, we're going to be adding 2 pi. So, okay, here we go. Forget about the negatives and forget about the pi. Let's go 8 divided by 3. Add 2 to it. Turn it back into a fraction. You end up with 14 pi over 3. What do I still need to do? Okay, now let's use our smarts. Let's look at the patterns. What am I going up by? 6 on top. What am I doing here? 6. So what do you think the next one's going to be? Negative 20 pi over 3. Thumbs up, thumbs down right now. Thumbs up, thumbs down. Okay, let's take this right now like it's a checkpoint quiz. Are you ready? Here's your problem. Just for time purposes, instead of doing 3 and 3, let's just do 2 and 2. Okay? Negative 5 pi over 3. If you feel confused or you need additional help, don't be afraid to ask your elbow partner, but first try it on your own. I want 2 positives and 2 negatives. Begin. is there anybody here I can help with this concept? Okay, can you do me a favor, 1 through 5 right now? What's your confidence level, 1 through 5? Not your speed, just your confidence. Most of us have 3 to 5s, okay? We're going to move on to the next one. Grab your calculator. This is like, you're not going to draw what I'm drawing. Okay, do not draw what I'm drawing. Literally have your calculator in hand ready to type in numbers immediately. I'm going to draw something very slowly, and I want you to come up with exactly how many degrees am I representing on this graph. You must have your calculator in hand. You ready? From here to here is 75 degrees. How many degrees did I represent from this point to this point? With the help of your partner, you have 15 seconds, go. Start talking, I should hear you talking. Your final answer ends in a 5. Okay, here we go. You ready? So watch. Does everybody see how I just did one revolution? So what do you have down right now then? Okay. Then I do another revolution. What do we have down? Then I do one quadrant. What is this quadrant? And then right here, this is 75. So what is up here?
15.
How did you get the 15? 825 degrees. God is with us always, depending on whoever your God is, right? But let's just stick to math. Okay, here's your next one. Okay, on your own, here we go. This remaining portion right here is 80. Do not shout out the answer. Amy, this is the wrong answer. Only Amy's answering. Amy, this is wrong. What did you get for an answer, Amy? Okay, that's all right to be confused. Henry, what did you get?
-440.
How'd you get negative 440?
Because we went clockwise instead of counterclockwise.
Okay, so you got negative 440. Do you agree or disagree with that? Let's go to Alondra. You agree with negative 440. How'd you come up with negative 440? Okay, so 360 once around. Okay, now what? Okay, so 90 here. And then what else? So I'm adding 90, 90 is 180. Okay. A 10. So what is 360 plus 180 plus 10? Anybody? It is a negative 550, right? Why is it a negative 550? Is there a counter? I love that Alondra explained it all. She gets it. Hey, Henry, just curious. Can you tell me what did you do wrong?
I didn't add 180 instead of 80.
Oh, there we go. Small mistake, right?
No.
Okay, we have 2 problems left. We do not have much time. So we have 1 minute left. These are your problems. You're going to do each problem in 20 seconds. You don't have to show any work if you don't want to. I want you to transfer that into a degrees. And I want you to transfer 15 degrees into radians as quick as you can. Go. Tomorrow, please listen up. We have one problem we have not got to. Tomorrow, it's important you're here. Santos here on time. Miguel here every day. Don't miss another day this year. If you're going to miss because you have AP testing, totally understand, obviously. But you need to be here every single day. Our goal is by Wednesday that we have completed 50% of your next test.